Okay, these notes are called empirical formulas. Okay, an empirical formula, or EF, which is how I'm going to be abbreviating it throughout these notes, is the lowest whole number ratio of elements in a compound. Now, ionic formulas are always empirical formulas. And if you recall, when we were putting the ions together, you always had to make sure that they were in the lowest whole number ratio. So ionic compounds are always empirical formulas. It's the covalent formulas that are not always empirical formulas. So if you look at C6H12O6, which is glucose, it actually has an empirical formula of CH2O. Because if you divide 6 by everything, you get this. So this is actually what's called the molecular formula. Your molecular formula actually tells you the exact ratio of elements in a compound, whereas the empirical formula is the lowest whole number ratio of elements in a compound. So we'll get to molecular formula tomorrow, but tonight it's the empirical formula. Okay, there are two ways to figure out the empirical formula of a compound. Using the percent composition of the compound, so all the stuff that we've been doing with the lab and everything else, where we're calculating the percent composition, well, now we're going to use the percent composition to figure out the empirical formula. So basically, we're going to go backwards. You can also use the amount, or the mass in grams, of each element in a sample of the compound. Okay, these are the basic steps. Okay, oops, let me move this. You have to replace the percent sign with the grams, So if it says like 1.3%, here, I'll write it on here. 1.3% carbon, say, that's actually going to be 1.30 grams. And the reason for that is you are assuming that there's a 100-gram sample, okay? Because you have to have this all in grams in order to figure out the empirical formula. So if you're given a percent, that's that percent out of 100 grams anyway, okay? So just pretend like it's 100 grams. So that's what you do. Change your percent into grams. Now, the next step is you're going to divide these grams with the molar mass. Now remember, the molar mass comes from the periodic table. So it's the molar mass of each element. For example, hydrogen is 1.01 grams per mole. Okay? Use the periodic table to figure that out. Okay, you'll get an answer. It gives you the number of moles basically in that sample. Divide everything by the smallest number of moles. So let's say you've got 0.33 moles and 0.98 moles. You're going to divide everything by the 0.33. Okay, so you're going to divide by this everything, all of it, by the smallest number of moles that you got when you calculated number 2. Now, if all these numbers are whole numbers, okay, so when you rounded to the nearest 0.5, you didn't have to, so it came out to be maybe 1.1 or 4.2. Anything that rounds to the nearest whole number, you've got the ratio. You don't have to worry about it anymore. But if you had to round to any 0.5, let's say you've got a 1.5 or a 0.5, probably not a 0.5, a 1.5 and a 1, okay, you have to multiply both of those by 2 because you have to have the nearest or the lowest whole number ratio. Okay, so you have to have the whole number ratio. Can't have any 0.5s in there. There aren't any such thing as half an atom. Okay, so to get that ratio, you've got to multiply by 2. Kind of like when we were balancing. Remember, if we left the C, it was the carbohydrate thingies, where it was the carbons and the hydrogens. And if the H was an odd number, and if you didn't put the 2 in there first, you ended up with a half of oxygen, like maybe 11.5 or 13.5 or something like that. You had to multiply everything by 2. Or you could have just started out with 2, but either way, you had to multiply by 2 because you can't have any halves of anything in chemistry, at least not in this stuff. Okay, so our first example, what is the empirical formula of a compound made from 7.8% carbon and 92.2% chlorine? Okay, the first step said we had to turn it into grams. So C equals 7.8 grams. Now I'm going to leave a big old space here, not a big space, but a little space. Chlorine equals 92.2 grams. Okay, Now the second step said you had to divide by the molar mass of each element. So the molar mass of carbon is 12.01 grams per mole. And when I divide that out, I get 0.649 moles. Now, the molar mass of chlorine is 35.45 grams per mole. And when I divide that out, I get 2.601 moles. Now, you don't have to worry about sig figs or anything like that. When you're doing these moles, I would go at least 3 places past the decimal if you can. 2 places you might not worry about it, but the more places you have out, the better the number is when you actually divide by the smallest number. Okay, but you don't have to go like 5 and 6 places past the decimal. Generally, 3 places past the decimal works fine. Okay, so let's look at this. We have 0.649 and 2.601. Well, this is the smallest, so we are going to divide both these numbers by 0.649 moles. Now when we do that, we get a 1. Obviously, you divide the number by itself, it's 1. And when you divide this one, you get a 4. Okay, so we now have our ratio. So there's 1 carbon, so this means there's 1 carbon and 4 chlorines. Now for your formula, what's listed in the problem? Okay, so this is listed first and this is listed second. So C comes first, then chlorine, because that's the way I've listed it in the problem. So you don't have to worry about, you don't have to figure out which goes first in the formula. So this is CCl4. Okay, so far so good, I hope. Okay, so let's look at this example. What is the empirical formula of a compound that contains 26.6% potassium, 35.4% chromium, and 38.0% oxygen? Okay, so we're going to first, K is 26.6 grams. Chromium is 35.4 grams. And oxygen is 38.0 grams. Now, we need to divide everything by the molar mass. So the molar mass of potassium is 39.10 grams per moles. So that gives you 0.680 moles. Okay, chromium is 52.0 grams per mole. 0.680 moles. Okay, it came out to be the same. That happens quite a bit. And oxygen is 16.0 grams per mole. When you divide that out, you get 2.375 moles. Now here, the smallest whole number ratio, or the smallest number of moles is 0.680. So we're going to divide all 3 of them by 0.680. 0.680 moles. Now when we do that, this becomes 1, this is 1. Unfortunately, when you do this, and since you have to round to the nearest 0.5, this comes out to be 3.5. Well, obviously, that's not a whole number. So now we got to multiply everything by 2. Oops, times 2, we get 7. Okay? So now it's K2Cr2O7. Okay, hopefully that's pretty easy. Okay, so what is the empirical formula of a compound that contains 3.74 grams of carbon and 1.26 grams of hydrogen? Well, if you'll notice, there's no percent, so we can actually skip that first step. We're already given the grams. We don't have to worry about changing it to grams. So I'm going to write, whoops, well, I would write carbon here, which is 3.74 grams, and our hydrogen, which is 1.26 grams. Now, we need to divide by the molar mass of carbon, and when we do that, we get 0.311 moles. And then we have hydrogen, which is 1.01 grams per mole, and it's 1.24 moles. Probably should have brought that number out, but in my original notes I didn't, and I don't feel like redoing the math, so this can stand. Okay, so we're going to take it, divide it by 0.311 moles. That's a 0. Okay, then we get a 1, and we get a 4, so it's CH4. So these are all pretty easy. You just got to remember, percents turn into grams, then you have to divide by the molar mass, then you have to divide by the smallest number of moles to get your whole number ratio. Multiply by 2 sometimes. That's probably the hardest part, is knowing when to multiply 2 and when not. But we'll keep working on it. We'll work on it tomorrow. We'll do warm-ups, and then hopefully you guys will get this and won't have any issues with it. So, that being said, I will see you guys tomorrow. Good night.